Saritha Kumari, Assistant Professor, working in Institute of Aeronautical Engineering College, Dundigal, Hyderabad. So, under the course Performance of Transmission Lines and Cables, the topic is representation of long transmission lines. It is mapped to course outcome 3. So, to represent a long transmission line, so we know that for medium transmission line, medium transmission line, there are 3 methods: end condenser method, medium transmission line, end condenser method, then nominal T method, nominal pi method. So for long transmission lines also, here we have 2 representations. So one is equivalent pi network and other one is equivalent T network. So first we see about the equivalent pi network for long line. So we know basically the idea about the pi network, right? How the pi network is, okay, for a transmission line, okay. So here the impedance is in pi network, total impedance is Z, and admittance is, total line admittance is divided into half, and each half is assumed to be concentrated at the sending end and also receiving end. So here that is what we see. So it is mentioned as equivalent pi network. So the sending end voltage current Vs and Is, okay, and the receiving end voltage current is Vr and Ir. And here transmission line impedance is taken Z dash, okay, Z dash. It is just taken like that notation, Z dash, and admittance is Y dash by 2, okay, at the sending end and also at the receiving end. Now we know from the idea previously we have seen for a transmission line, if the circuit is a pi network, so how the sending end voltage, okay, sending end current related with the receiving end voltage, receiving end current. So equations we know. So in terms of the line impedance and line admittance, so that is what it is mentioned here. It is considered here in terms of this Z dash and Y dash. Okay. So per pi network, Vs and Is is equal to, so in a matrix, okay, in a matrix. So we know that first A is given by, so if it is ABCD constant, so first A is given by 1 plus Yz by 2. Here Yz is Y dash, Z is Z dash. So Y dash, Z dash by 2. And B constant is Z dash for equivalent pi network. Okay. So B is given by Z dash and C constant is given by Y dash into 1 plus 1 by 4 Y dash, Z dash, and D is given by A, that is equal to A, so 1 plus Yz by 2. So Yz means here Y dash and Z dash for the network shown above. So into VR into IR. Now consider Vs and Is equations for the long transmission line. So we know for long transmission line, okay, Vs and Is is equal to, okay, that is what in the previous lecture we have seen. So this is cos h gamma l, B constant is Zc sin h gamma l, and C constant is 1 by Zc sin h gamma l, and D is cos h gamma l into VR into IR. So say that previous one, equation 1, okay, previous slide, Vs and Is, okay, equation in terms of the matrix. So equation 1, now it is equation 2. Now comparing, okay, equating both 1 and 2 equations, okay, what we will get. So here it is written as, previously we know that in this place 1 plus Yz Z dash by 2, okay, so that is equated to cos h gamma l, okay. Then also consider in this place previously what we have, Z dash, right, previous line. So we have this equation, so this is equated to cos h gamma l, and B is this Z dash is equated to Z dash is equated to ZC sin H gamma L. Say that equation number 3, equation number 4. Equation number 3, this is equation number 4. Now, see that from equation 3, Z dash is equal to ZC sin H gamma L. What is ZC? We know that it is called as characteristic impedance. It is given as square root of small z by small y. Okay. Now here multiply and divide with sin gamma L. Multiply and divide with gamma L. So we know that next step, write down sin H gamma L by gamma L at one place. Okay. This whole thing at one place. So sin H gamma L by gamma L at one place. Next step, into gamma L. Now we know from the definition how gamma is given. It is called as propagation constant. It is given as square root of small z into small y. Okay. So that is what gamma. Square root of yz. Now cancel this y, numerator and denominator, and square root small z into square root small z becomes what? Z, right? Small z into L. And now we know that what is that small z into L? Capital Z, right? Capital Z. So, and sin H gamma L by gamma L keeping as it is. Okay. So, keeping sin H gamma L by gamma L as it is, not not disturbed. So now what is Z dash? This Z dash is given by in terms of line parameters as capital Z into sin H gamma L by gamma L. Okay. Then consider equation 4. What is equation 4? 1 plus half into z dash y dash into z dash y dash is equal to cos H gamma. Now, in place of z dash, substitute. In place of z dash, we know that from equation 3. Okay, that is what it is mentioned here. Substituting z dash from equation 3. So, ZC sin H gamma L. So, therefore, from this, y dash by 2, writing y dash by 2 is, okay. So, taking the other things to right side. So, cos H gamma L minus 1 by sin H gamma L. Cos H gamma L minus 1 by sin H gamma L into 1 by ZC. Now, we know that what is ZC? Characteristic impedance is given by square root of small z by y. 1 by ZC means square root of small y by small z. Now, also simplify this, okay, from the basic mathematics knowledge. So, cos H gamma L minus 1, cos H theta minus 1, 2 sin square H gamma L by 2, right? And what is sin theta? 2 sin theta by 2, cos theta by 2. Okay, cancelling sin theta and numerator and denominator, and 2 also. Finally, what we will get? Sin by cos is left. So, which is finally given as tan theta by 2. So, here theta is nothing but gamma L. So, tan H 1 by ZC into tan H gamma L by 2. Now, further simplifying. We know that 1 by ZC, capital ZC is square root of y by z, and tan HL by 2, tan H gamma L by 2 into multiply and divide with gamma L by 2. Okay, multiply and divide with gamma L by 2. So, it is written as gamma L by 2. Okay, so it is written at one place. Okay, tan theta by theta, keeping it at one place. So, remaining what is left? Square root small y by z into gamma L by 2. So, now, what is gamma? We know that. What is gamma? Square root of yz, small yz. So, z, numerator and denominator gets cancelled. So, square root small y into square root small y becomes Okay, y into L by 2 tan h gamma L by 2 by gamma L by 2. Now we know that small y into L becomes capital Y. Small y into L is capital Y. So total admittance of the line. So y dash by 2 is given by y by 2 into tan h gamma L by 2 by gamma L by 2. So that is what that is how z dash and y dash by 2 are calculated, okay, from the equations. Now see, finally we are giving equivalent pi model, equivalent pi network for the long transmission line. Okay, so we know that impedance is, total impedance is z dash, okay, and admittance is at both sides y dash by 2. So we have now what is y dash by 2, what is y dash by 2, y capital Y by 2 into tan h gamma L by 2 by gamma. What is z dash, capital Z into sin h gamma L by gamma L, right? So that is what finally it is shown for the long transmission line. Equivalent pi model, pi network, total impedance is given by, okay, Z into sin h gamma L by gamma L. Okay, that is represented with Z dash, and y dash by 2 admittance is y by 2 into tan h gamma L by 2 by gamma. That means what? Okay, in the pi model impedance for the long transmission line, impedance is multiplied with the another factor for the long transmission line. What is that factor? Sin h gamma L by gamma L. So sin, that is what it is mentioned. Okay, so sin h gamma L by gamma L is a factor by which series impedance of nominal pi must be multiplied to obtain Z dash parameter of the equivalent pi. Okay, sin h gamma L by gamma L is a factor, okay, by which the series impedance of the nominal pi must be multiplied to get the total impedance of the long line. That means equivalent pi. Next, what about admittance? What is the additional factor here? Tan h gamma L by 2 by gamma L by 2 is a factor by which shunt admittance of the nominal pi must be multiplied to obtain the shunt parameter of the equivalent pi. Next, in the same manner, equivalent T. In the same manner, equivalent T network for the long transmission line. So we know that how the T network basically for the transmission line. Transmission line total admittance is taken as Y, taken at the middle of the line, okay, and impedance is taken, okay, divided into two parts, that is Z by 2, and taken one at the sending end, another half at the receiving end. Okay, so that is what basically T network for the transmission line. So here, like previous thing, here also impedance is taken Z dash, okay, and admittance also taken Y dash. Okay, so because it is Z is half, so Z dash by 2, Z dash by 2, Y dash is Y dash. Now, basically we need to recollect for the T network how the two equations of Vs and Is. Okay, so as we know, these two are same as pi network, that is 1 plus yz by 2. Okay, 1 plus yz by 2. Only these B and C values are changed. So previously it is only Z. Now it is Z into here we have for the multiplication factor. Okay, Z into 1 plus 1 by 4 yz, and C is Y. Okay, so that is how the T network representation. Now for the long transmission line, compare this with the long transmission line Vs and Is equations. So that is given by, this is cos h gamma L, okay, Zc sin h gamma L, Bc is 1 by Zc sin h gamma L, D is cos h gamma. Now compare, okay, equating the equations, 7 and 8, equation numbers are given, 7 and 8. So what we will get? So here it is given by, consider these two, okay. So one is 1 plus yz by 2, y dash z dash by 2 is equal to cos h gamma L. Another one is, which one is the simpler one? Look at the previous line. So what is the previous simple one is? Simple one. So consider this one, y dash, c constant. Compare c constant. So y dash is equal to 1 by zc sin h gamma L. Now first find out y dash by 2, y dash, okay, then we can find z dash by 2. So y dash is 1 by capital Zc sin h gamma L. Okay, write down what is Zc, square root of y by z, small y by small z, and multiply and divide with gamma L. Now, so again the same manner, sin h gamma L by gamma L, keeping aside, okay, and substitute for gamma L. What is gamma L? Square root of yz into L. So z get cancelled, square of small y into square of small y becomes small y into L. It becomes capital Y. Sin h gamma L by, okay, gamma L. So what is y dash? Capital Y dash, y into sin h gamma L by gamma L. Now from equation 10. So here substitute for y dash, okay, substitute for y dash. So writing z dash by 2, z dash by 2 is equal to, okay, writing the remaining things to other side, Zc into cos h gamma L minus 1 by sin h gamma L. So again from the knowledge of basic mathematics, so solve it. Simply, finally solving this, we will get, this is 2 sin square theta, this is 2 sin theta cos theta. So numerator denominator sin theta gets cancelled. Finally we will get cos theta by sin theta by 2. So tan h, finally what is that? Sin h theta by 2. Now what is Zc? Square root of small y z by small y, and multiply and divide with gamma L by 2 here. Okay. Now writing this tan h gamma L by 2 by gamma L by 2 aside and substitute for gamma L by 2. What is gamma L by 2? Gamma is square root of yz. Square root yz. So y gets cancelled and small z into small z under root becomes z, small z into L. That becomes capital Z. Capital Z by, so Z dash by 2 is given by Z by 2 into tan H gamma L by 2 by gamma L by 2. So finally what are the parameters of equivalency network of long transmission line? So remember like this, okay, only half, what is that half thing here in the T network, Z, right? So Z by 2 multiplied with tan, okay, tan gamma L by tan H gamma L by 2 by gamma L by 2, okay, and the total admittance becomes y dash y into sin H gamma L by gamma L. So this is additional term for the shunt admittance, and this is additional term for the series impedance. So that is what it is mentioned here. Okay, sin h gamma L by gamma L is a factor by which the shunt admittance of nominal T must be multiplied to obtain the Y parameter of the equivalent. And tan h gamma L by 2 by gamma L is a factor by which series impedance of the nominal T must be multiplied to obtain the series parameter Z dash by 2 of the equivalent T. Okay, so That is how the representation of long transmission line. Okay, that means equivalent pi network, equivalent T network. Okay, so what are the additional terms? These are the additional terms. So that's all for this lecture, and these are the reference textbooks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.